Wow! You've just scraped HTML data from the web, and you've done so using two different packages, URL-lib and requests. You also saw that requests provided a higher level interface, in that you needed to write fewer lines of code to retrieve the relevant HTML as a string. You've got the HTML of your page of interest, but generally, HTML is a humble jumble mix of both unstructured and structured data. A few words on these terms. Structured data is data that has a predefined data model or that is organized in a defined manner. Unstructured data is data that does not possess either of these properties. HTML is interesting because, although much of it is unstructured text, it does contain tags that determine where, for example, headings can be found, and hyperlinks. In general, to turn HTML that you have scraped from the World Wide Web into useful data, you'll need to parse it and extract structured data from it. In this video, and the next few interactive exercises, we'll provide a brief introduction to how you can perform such tasks using the Python package Beautiful Soup. Let's now check out the package's website. The first words at the top are, "You didn't write that awful page. You're just trying to get some data out of it. Beautiful Soup is here to help." Since 2004, it's been saving programmers hours or days of work on quick turnaround screen scraping projects. Firstly, a word on the name of the package. Beautiful Soup? In web development, the term tag soup refers to structurally or syntactically incorrect HTML code written for a web page. What Beautiful Soup does best is to make tag soup beautiful again and to extract information from it with ease. In fact, the main object created and queried when using this package is called Beautiful Soup, and it has a very important associated method called prettify. Let's now see Beautiful Soup in beautiful action. Once again, you use requests to scrape the HTML from the web. Then you create a Beautiful Soup object from the resulting HTML and prettify it. Printing the prettified soup and the original HTML, you can see, for example, that the prettified soup is indented in the way you would expect properly written HTML to be. You'll explore a few of the methods that you can apply to your soupified HTML in the following exercises, such as title and getText, which extract the title and text respectively. You'll also work with the soupy method findAll in order to extract the URLs of all the hyperlinks in the HTML. These are merely a few of the many methods existing in Beautiful Soup to extract data from HTML. If, after completing these exercises, you find yourself thirsting for more Beautiful Soup, there are plenty of great resources on their website. Okay, now it's your turn to jump into the deep end of the proverbial soup bowl. Happy hacking! In this chapter, you'll explore pulling data from the web even further by learning how to interact with APIs, or application programming interfaces. An API is a set of protocols and routines for building and interacting with software applications. In particular, you'll learn how to use the Open Movie Database API, and in the next chapter, the Twitter API to pull data from both applications, while learning about API interaction best practices. A standard form for transferring data through APIs is the JSON file format, so in this video, we'll focus our attention squarely on these. Then we'll move on to actually getting data from APIs. JSON is an acronym that is short for JavaScript Object Notation. It's a file format that arose out of a growing need for real-time server-to-browser communication that wouldn't necessarily rely on Flash or Java, and was first specified and also popularized by Douglas Crockford, an American programmer and entrepreneur. One of the cool things about JSONs is that they're human-readable. That is, they can naturally be read by humans, unlike, for example, pickled files, as we saw in the previous course. As they're human-readable, let's check one out. Here you see a JSON from the OMDB, or Open Movie Database API. In particular, this is a JSON containing information about the movie Snakes on a Plane. First, notice that the JSON consists of name-value pairs separated by commas. This will remind you of the key-value pairs in a Python dictionary. We'll see in a minute that, for this reason, when loading JSONs into Python, it is natural to store them in a dict. The keys in JSONs will always be strings enclosed in question marks. The values can be strings, integers, arrays, or even objects. Such an object can even be a JSON, and then you have nested JSONs, but we won't go further into these here. In the case of the snakes on a plane JSON, all the values are strings, and we can see this from the quotation marks. The value corresponding to the key title is the title of the movie as a string, Snakes on a Plane. The value corresponding to the key year is the year of release as a string, 2006, and so on. There's the rating, the runtime, director, writers, plot, language, and much more. You'll soon learn how to use the OMDB API and Python to automate retrieval of such data. But first, you'll figure out how to load JSONs from a local directory. Let's say that I had the JSON stored in my working directory as snakes.json. To load the JSON into my Python environment, I would first import the package JSON, and then open a connection to the file and use the function json.load to load the JSON. If I then check the data type of JSON data by executing type JSON data, I see that Python cleverly imported the JSON as a dictionary. To print the key value pairs to the console, I can then iterate over the key value pairs using a for loop. Now it's your turn to test your JSON skills, so get coding.